Hi, in this video we're going to look at seasonal indices and using those to deseasonalize our data. Now the purpose of this is that most of our economic and financial data is subject to seasonal fluctuations. We might find that sales might be higher in summer or winter, or even days of the week or certain months of the year. Now the process of deseasonalizing our data means that we remove those fluctuations that are due to the time of the year and allows us to see overall trends. Seasonal indices tell us how a typical season compares to the average season. So if all of our seasons that we're looking at are the same, then our seasonal index for each one of those is going to be 1. If the seasonal index for monthly sales or quarterly sales was 1.3, then it means that the sales figure for that period was 30% higher than average monthly sales. Similarly, if the seasonal index was 0.7, then it means that for that month or quarter or period, the sales figure was 30% lower than the average. Now to calculate our seasonal index, we divide our original data value by the seasonal or yearly average. Please note that this is going to give a seasonal index for 1 year or one cycle period that we're looking at. For multiple years, you need to calculate an average seasonal index to get your seasonal index that you're going to use. This is now used to deseasonalize the data, which is also known as our seasonally adjusted data. So to do this, we have our actual data that we started with, and we're going to divide it by the seasonal index that we have just calculated. So let's summarize what we need to do. To calculate our seasonal indices, we need to find the yearly average, or the average of the cycle we're looking at. Divide each value by the yearly average to get our simple seasonal index, and then to calculate the average for each of those seasons to give our final seasonal index that we're going to use. Once we have done that, we can deseasonalize our data by having the actual data and dividing it with the seasonal index. Now in this video we're going to look at the example in our text, which has new homes built by a company, and we're going to calculate the seasonal indices, we're going to deseasonalize the data, and finally we're going to graph this and have a look at what's happening. Now to do this, it's actually easier if we organise all of this data into a single column. So I've arranged it into our years, our quarters of each year, and the number of new homes built each quarter are arranged in a single column. I apologise that the bottom row is missing. The next thing to do is we need to calculate our yearly seasonal average. So we're going to add up our new homes built for the whole year and divide it by the number of quarters. So the yearly average for each quarter in 2017 was 15. For each quarter, the average was 15.25 for 2018. And then once again in 2019, the average for each quarter was 15. Once we've done that, we're going to calculate our 1 year seasonal index. So it's going to be our data values divided by our yearly or seasonal values. So for quarter 1 of 2017, it's going to be 14 divided by 15. For quarter 2, it's going to be 15 divided by 15, and so on. And that gives us our indexes for our first year, and our second year, and our third year. But what we want to do is we want to create average seasonal indices over the entire 3 years. So what we're going to do is we will calculate our average seasonal index for our first quarter of 2017, our second quarter of 2018, our third quarter of 2019, our fourth quarter of 2019, our fifth quarter of 2019, our sixth quarter of 2019, our seventh quarter of 2019, our eighth quarter of 2019, our ninth quarter of 2019, our 10th quarter of 2019, our 11th quarter of 2019, our 12th quarter of 2019, our 13th quarter of 2019, our 14th quarter of 2019, our 15th quarter of 2019, our 16th quarter of 2019, our 17th quarter of 2019, our 18th quarter of 2019, our 19th quarter of 2019, our 20th quarter of 2019, our 21st quarter of 2019, our 22nd quarter of 2019, our 23rd quarter of 2019, our 24th quarter of 2019, our 25th quarter of 2019, our 26th quarter of 2019, our 27th quarter of 2019, our 28th quarter of 2019, our 29th quarter of 2019, our 30th quarter of 2019, our 31st quarter of 2019, our 32nd quarter of 2019, our 33rd quarter of 2018 and 2019. Add those up, divide by 3, and that gives us our seasonal index for our first quarter. Then what we do is we do the same thing for our second quarter. 1 plus 36, plus 0.9836 plus 1.0667, divide that by 3 to give us our seasonal index averaged over 3 years for our second quarter. These values are going to be the same for each of those years because we've used 3 years of data to calculate those. Now, here we are at our final step of deseasonalising our data. So our deseasonalised data is going to be our original data divided by the seasonal index. So 14 divided by 0.9282. And that gives us a deseasonalised data of 15.083. And we're going to do that for each one of those values. So for quarter 2 of 2017, it's going to be 15 divided by our seasonal index to give us 14.752. So now we have deseasonalised all our data. To see what this looks like, we're going to graph this. So here it is graphed. The blue is the original time series data, and you can see that there's some big fluctuations up and down in a cyclical nature. What we have now done is we've deseasonalised the data. So you can see it's smoothed out a lot of those peaks and troughs. If we want to describe the trend, we can see that there, we'll remove the fluctuations, but there may well be a slight downward trend. Here's another graph showing in black our original data and in red our deseasonalised data. Now if we have a look at this period between quarter 4 and quarter 1 in 2018 to 2019, it looks like the profits, because that's what's on our y-axis, are going down considerably. But what we can see by our deseasonalised data, that in our first quarter sales are low. And if you look from here to there, sales have gone up. If you look at what's happened here from quarter 4 to quarter 1 on our deseasonalised data, even though the actual sales have gone down, the expected sales for that period of time have actually increased. And we can see that overall there's an upward trend in the amount of profits for this company. So I hope that's helped explain this, but see me if you need any further explanations. Thank you.